This is Zohina Abdul Asif and I am lecturing computer science. We are going to continue our software requirement engineering topic. In the last session, we have covered introduction to requirement engineering, the impact of requirement engineering, its importance, and we have covered W4H of requirement engineering. In the last, we have covered levels of requirement engineering. In today's lecture, we are going to cover ambiguous requirement engineering. What is ambiguous requirement engineering? What are the characteristics of good requirement, the quality factor, and the task in requirement engineering that should be followed to implement requirement engineering. So the first and the foremost is ambiguous requirement engineering. Ambiguous, as it clear from its name, ambiguous means unclear, vague, leading to unknown direction. So when we combine these two things, it becomes unclear, vague, and something that lead to us to the way where it's create confusion among stakeholder, developers, and testers. It becomes ambiguous requirements. For example, the system should load fast. So here, fast, what does fast mean? 1 second, 5 seconds, or more. Another one, the software should be user friendly. What does user friendly actually mean? Use for whom? What usability criteria should it follow? And much more. Generate reports regularly. So here is a word regularly. What does this regularly means? Daily, weekly, or monthly? What are the basic causes of ambiguous requirement? It could be poor communication with stakeholders, use of subjective language, just we have used in last, fast, user-friendly, and etc. Lack of domain knowledge, missing acceptance criteria, and so on. What problems it causes? Misunderstanding between client and developers, delay due to rework and clarification, high project costs, and defects in final system. Here are some steps through which we can avoid ambiguity. Use clear, measurable, and testable language. Define terms precisely. System must respond within 2 seconds. System must be user-friendly. That means the customer can use it properly. Use models and diagrams to support textual requirement. Review and validate requirement with stakeholders. Characteristics of good requirements should be numbered, which means the requirement should be listed down in such a way that most important one comes first and the least important comes last. Inspected, the requirements should be properly inspected and gathered accordingly. And ambiguous, the requirement should be clear, testable. All the requirements that we have implemented can be tested through any mechanism. Complete, it shouldn't be incomplete, since we have seen there are issues when the requirements are incomplete or inconsistent. Understandable. This is a very important point. The requirement should be understandable, because when customer and developers couldn't understand the requirement, there is a feasibility that the requirement cannot be implemented. Traceable. That means when you implement some certain requirement, it should be traceable, it should be trackable. Feasible, it should be it shouldn't be like it could have been done for a certain scenario. Modifiable means the requirement could be changed over time, or it entertain change over time. Okay, so here is a task for all of you. Write down 5 functional requirements and 5 non-functional requirements of our mobile telephones. I'll wait for 30 seconds and you write it in comments. I hope you have written all the requirements in the comments below. I'll check it down and let you know who has written them correctly and who haven't attempted it properly, and I will guide it through how you identify functional and non-functional requirements. I have another task for all of you. Write down 5 functional requirements and non-functional requirements of an online examination system. Take a pause and write it down. You can write it down in comment section. I'll check it down and let you know who has identified it clearly and who have missed the exact requirements. Thank you so much. So, quality factor. What are the quality factors of requirements? A good requirement. The good requirement should be portable. Portable means it could be adjustable with other. Reusability, which means we should implement them in such a way that they can be used later. Interoperability, that means a system should be operated in multiple platforms. Survivability, it should be a sustainable. Safety, it ensures security of data. Manageability, as we said, good requirement should be manageable, which means that we can manage how to work on it, how to implement it, how to communicate it, and how to make changes in it. Supportability, it should support our main goal. Replaceability, if in by chance there is a change in requirement, we should be able to replace that particular requirement rather than changing whole system. Functionality, the system should be completely functional. Correctness, it should be aligned to our acceptance criteria. Reliability, the requirement should be reliable. That means it shouldn't crash in times when it should be working. Efficiency, the performance of the requirement should be according to our standards, and so on and so forth. There are certain problems that we face when we practice our requirement gathering mechanism. We face trouble when we need to understand requirements. Our mechanism to organize requirements are often vague. We spend a very few time to verify what we have recorded. We don't allow the change to control us. That's how we fail to establish a solid foundation for the system or software that our user want to build. So, requirement engineering tasks. There are actually 7 tasks in requirement engineering. First, inception, elicitation, elaboration, negotiation, specification, validation, requirement management. We follow all these requirement engineering tasks to avoid the problems we have discussed in previous slide. Some of these tasks may occur parallel. That means both there may be overlapping of the tasks, but they are adaptable. I'll start to define what we customer wants. These are designed to the demand of the customer. All are served to establish a solid foundation for design and construction of software. Okay, the very first step is inception. Inception, we identify the project scope, key stakeholder, and initial system goals. The purpose of inception is to establish a clear understanding of what the project is about and who is involved in the system. Make sure you remember this: what project is about and who is involved, which means what a system do, it's the business goal, right? And who is involved, the stakeholders, right? So in inception, the requirement engineers set up certain questions that towards their basic understanding of the problem the people who want to solve this problem, results required, and effectiveness of the problem. These questions helps requirement engineer to identify the stakeholder, multiple viewpoints, work collaboration, and break ice between and initiate communication. That means it is a way to start a communication with our stakeholders and to develop understanding between team and to identify the actual goal of the project. So this is an actually a crucial point of requirement engineering. So in inception, the first set of questions are, these questions focus on customer, other stakeholders, and all goals and benefit. Who is behind the request of this work? Who will use this solution? What will be the economic benefit of successful solution? Is there another source for the solution that you need? So let's suppose I'm going to do an e-commerce website. So who is developing? Business owner, who will be used, the person who will be purchasing the product. What kind of the purchase I'm going to do, be in this e-commerce website determines the age group, gender, or might be possible the people's are region of the people who are going to use this website, right? So this is the very first question of inception. So these questions enable requirement engineer to gain a better understanding of the problem and allow customer to voice order. For example, how will you characterize good output that would be generated by a successful solution? What problems will this solution address? Can you show me the business environment in which this solution will be used? Will special performance issues or constraints affect the way solution approached? So here are the final set of questions that a requirement engineer will ask in inception. These questions focus on the effectiveness of communication activity itself. So here are the parts of it. Are you the right person to answer these questions? So are the person who is answering the question are officials or not? Are any questions relevant to the problem that you have? Am I asking too many questions, or it's generally a thing that represent if the questions are not irrelevant? Can anyone else provide additional information? Who else can answer the solution? Should I ask you anything else? Is there anything I have left or I haven't overseen that I should have asked you? This thing comes in this phase. Okay, moving on. So we have done inception. In this inception, we identify what the problem we are going to solve and who is the person who will be involved in the solution and who is the person who is going to initiate that solution, the business person. And now we are going to discuss the second step in requirement engineering, that is elicitation. Elicitation, we gather raw requirements from stakeholders using interviews, surveys, and observations. In this step we do this, and the purpose of this is to capture all the possible need, expectations, and constraint of the system. So remember these two things in here. Elicitation task. Eliciting requirements is difficult because problem of the scope is to be identified in this, in which we identify what area should be addressed by this problem. Problems understanding what is wanted, what the problem domain is, and what the computing environment can handle this type of problem. Problem volatility, because the requirement change over time. Elicitation may be accomplished through two activities: collaborative requirement gathering and quality function deployment. So this is how elicitation task works. So here are the guidelines to collaborate meeting requirements. In last time we have said that elicitation can be done in two ways. The first one is elaboration requirement gathering. In this, meetings are conducted and attended by both software engineer, customer, and other interested stakeholders. Rules for preparation and participation are established. An agenda is suggested that is formal enough to cover all important points but informal enough to encourage the free flow of ideas. A facilitator, as we had discussed this already in agile methodology, a facilitator controls the meeting. A definition mechanism is used, such as worksheet, flip cards, wall stickers, electronic bullets, chat room, etc. that will be used for this meeting. The goal is to identify problem, the purpose and of the solution, and to negotiate between different elements, specifically a primary set of solution and requirements. So quality function deployment, this second step in an way to do elicitation thing. This is a technique that translates the need of customer into technical requirement or software. So here is its definition. Okay, pardon me for my bad drawing. Okay, this is a technique, it's a way that translate the needs of the customer into a technical requirement for software. Okay, it emphasizes on understanding what is valuable to the customer, then deploys these values throughout the engineering process and through functions, information, and tasks. It identifies three types of requirements. Normal requirements, these requirements are the objective and goals stated for the product. Expected requirements, these requirements are implicit to the product or survey and may be so functional that customer does not explicitly state. Exciting requirement, these requirements are there for the feature that go beyond. Okay, so just suppose we have a system that, let's say we have to design a calculator, right? The mechanism of the calculator is plus, minus, multiplication, and division, and all those, right? These are the normal requirements. But what would be the expected requirement? The client must be expecting that we will be implementing a modulus, right, percentage, or maybe an equals, or maybe we have a bit of other functionalities. What are exciting requirement? Exciting requirement would be that we implement, for instance, the functionality of cos, sine, and tan in this particular calculator. So these are three different domains of requirements that we cover in quality factor deployment. So the process of quality factor deployment to achieve the following is achieve its desired result, we do the following: identify the stakeholders, attributes or requirement, identify technical features of the requirement, relate the requirement to the technical feature, conduct an evaluation and competing product, evaluate technical feature and specify a target value for each feature, and prioritize technical feature for the deployment, the effort. So here is a picture, diagram that represent requirement gathering method. Conduct meeting, make list of functional classes, make list of constraints. If yes, use quality function deployment. If not, informally prioritize requirement and create use cases. In the use cases, we actually do draw use case diagram, define actors, write scenarios, complete templates. So this is a basic diagram that illustrate how illicit requirements work out. So we have covered inception, elicitation, and now we are going to discuss about elaboration. Elaboration is a process of analyzing, refining, and expanding user requirement to create precise, unambiguous, and detailed function and non-functional requirement that can guide system design and development. The purpose is to transform initial raw requirement into well-defined specification, resolve ambiguities and remove contradiction in requirement gathering, and to ensure requirements are complete, constant, and visible. Okay, how these things helps out in how these modeling of the requirements helps out in this phase. This provide first technical representation of the system, which is easy to understand and maintain, deals with the problem of size by partitioning the system, use graphics whenever possible, differentiate between essential information versus implementation information, helps in tracking and evaluation interface, provides tool other than narrative text to describe software logic and policy. Analysis rule of thumb. The analysis model should focus on requirements that are visible within the problem or business domain. The level of abstraction should be relatively high. More concerned about what we will implement, not worried about how we will implement. Each element of analysis model should add to an overall understanding of software requirement and provide insight into the following: information domain, function, and behavior of the system. The model should provide value to all stakeholders. The model should be kept as simple as it can be. Analysis modeling approaches: structure analysis or object-oriented analysis. There are basically two methods. One is this, and the other one is this. In structure analysis, consider data and the processes that transform the data as separate entities. Data is modeled in terms of any attribute and relationship, but no operation. Processes are modeled to show input data, transformation that occurs on the data, and the resulting of the output. So, object-oriented analysis focus on the definition of classes and the manner in which they collaborate. So this is how analysis model approaches. Element of the analysis model. In the structured, we have data structures, diagrams, data flow diagrams, control diagrams, and process model. In object-oriented analysis, we have scenario-based modeling, in which we have use case text, use case diagrams, activity, and swim lane. Class-based modeling, class diagram, class analysis, CRC models, and collaboration. Behavior modeling, state diagrams, and sequence diagram. So this overall give you an idea how we model things and how we align things to define certain kind of things. Keep in mind, when you are designing certain project, there will be a differentiation between what kind of diagrams will be created for what kind of project. There is a clearly mistake that most students create. For us object-oriented analysis, they make structure analysis diagrams, and for us structure analysis, they make all these diagrams. So as we have seen in modeling, that there is a modeling technique that we call CRC, that is class responsibility collaboration cards. Class responsibility cards are divided into three parts, basically: class name, its responsibility and its collaboration. We will see what responsibilities are and what collaborators are. Responsibility is anything that class knows or does, right? Something class will have responsibility to fulfill but will not have enough information to do. When it happens, it has to collaborate with the other classes. So a CRC model is a collection of CRC cards that represent whole or a part of application or problem domain. The most common use of CRC model is to rather and define gather is to gather and define the user's requirement for an object-oriented application. Collaborating cards are placed close to each other. Here's its implementation. So in this is kind of an e-commerce website that we have been representing. Here is a class of order, and order have these responsibility, but order could not have any information about the customer or the order item. So the customer and the order item is placed close to them. So the customer information will be in a customer class which has its responsibilities, and it has whose customer with what order. So its order and the surface address. The surface address information will be stored in the surface address class, and its information is here. So the here order item has inventory item. Inventory item is not known by order item, so it is in collaboration cell, and then it refers to inventory item class, in which inventory item has all the responsibilities of inventory item. Moving on, creating a CRC model. What should we do when we are creating a CRC model? Put together all CRC models team, organize a modeling room, do some brainstorming, explain CRC modeling techniques, iteratively perform the steps of CRC modeling, perform use case scenario testing. CRC team contains business domain expert, facilitators, scripts, and so room preparation include reserve a meeting room, bring CRC modeling supplies, have a modeling table, have a chair, desk, BDs, and chair observers. So then we have second task to do, brainstorming. Brainstorming set of questions that determines who is the system for, why it do, how it do, who will do, what are the functional requirements, what are the non-functional requirements, which class collaborate with whom, and all those stuff will be answered in this phase. We will explain the techniques of CRC models. Facilitator should describe the CRC modeling process. This usually takes between 10 to 15 minutes and will often include the creation of several examples CRC cards. BD's through creation will, for example, CRC card. There will be iteration performed on the CRC. Find classes. Look for anything that iteration with that interacts with the system or a part of the system. Ask yourself question: is there a customer? Follow the money. Look for the reports. Look for the screens. Immediately prototyping interface and report classes. Look for the 3 to 5 main class right away. Create a new card for a class immediately. Use 1 or 2 cards. What describe the class, and class names are singulars. Define responsibilities. Ask yourself what class knows and what class does not know. And some collaboration, what class does not know comes in the collaboration. Define use cases and arrange the cards into the table. Perform use case testing, call out a new scenarios, determine which card should handle the responsibility, update the card wherever necessary, discuss processing logic, collaborate if necessary, pass the ball back when done. So here the how this modeling fits in. Use case models, user interface prototype, both collaborate with a CRC model and create a class model. CRC modeling tips and techniques. Send I had an agenda a few days before the modeling session, prominently describe the CRC definition, use their terminology, keep it low tech, expect the to prototype, expect to take a few days, get management support, include a CRC modeling in your system development life cycle, do CRC modeling with frontline staff only. What are the advantages of CRC? So it gives an expert analysis, user participation increase, breakdown of communication barriers, simple and straightforward, non-threatening to users. It's inexpensive and portable. It goes hands in hand and it lead directly into class diagramming. Disadvantages of CRC modeling: it's threatening to some developers. It's hard to get users together. CRC cars are limited. So up till now we have covered inception, illustration, elaboration. Now we're going to discuss about negotiation. Negotiation is a way to resolve conflicts and prioritize requirements and reach an agreement with stakeholders. The purpose of negotiation is to rebalance stakeholders' needs and assure feasible agreed upon requirements. Negotiation tasks. During this task, software engineering reconciles the conflicts between what customer want and what we can achieve in given resources. Requirements are ranked by customer, user, and the stakeholder. Risk analysis has been done, and we identified the potential risk of implementing certain thing and how these risks can be resolved. Rough guesses of development efforts and project cost estimation are all happen in this stage. What are the some techniques that we can use for negotiation? Recognize it's not first of all, we should understand that negotiation is not a competition. We should map a strategy. We should listen to the other person actively, focus on the other party interests, and don't let it get personal. Be creative and be ready to commit. So for here we have covered these 4 steps, and we are reached to the step specification. So specification, we finalize requirement formally in the software requirements specification. Its purpose is to provide a clear reference document for design and development and tester. Is a final product. Okay, we have discussed this. It serves as a foundation and a subsequent software engineering activity. It describes the function and performance of a computer-based system and constraint that will govern its development. It formalizes the information, functional, and behavior requirement of software in broad graphical and textual format. So here are software requirement specification template. It contains introduction contains purpose, scope, acronyms, abbreviations, references, review, general description, and all this stuff. So up till here we have covered inception, illustration, elaboration, negotiation, specification. Now we are at the 6th stage, that is validation. Validation: review and verify requirements for correctness, completeness, and feasibility. The purpose is to ensure that requirements truly represent stakeholder needs and realistic. Validation tasks. During this phase, what product produced as a result of requirement engineering are assessed for quality. The specification is examined to ensure that all software requirements are met unambiguously, inconsistent omission and errors are being excluded. The work product confirm the standards established for the process and the project and product. The formal and technical review serve the primary requirement validation mechanism. Members include software engineer and customer needs. Questions that should ask at this stage are: each requirement consists with the overall objective of the system? Have all requirements have been specified at the proper level of abstraction? That is, do some requirement provide a level of technical details that is inappropriate at this stage? Is the requirement really necessary or does it represent add-on feature that may not be essential for the project? Is each requirement bounded and unambiguous? Does each requirement have attribution, that is a source noted for each requirement? Do any requirement conflict with other requirements? Is each requirement achievable in the technical environment? Is each requirement testable? Does the requirement model properly reflects the information, function, and behavior of the system built? Has the requirement model has been partitioned the way that explains more detailed information about the system? So, covered inception, elicitation, elaboration, negotiation, specification, validation, and the last we are going to discuss a requirement in management. Control requirement, change, track, vision, maintain consistency throughout the project. Its purpose to handle evolving requirements and prevent scope creep during development. So, during this stage, the project team perform a set of activities that includes identify, control, and track requirements and change to the requirement through at any time of the project. Each requirement is assigned a unique identifier. The requirements are then placed into a more traceable table. These tables may be sorted in database or other related features. Requirement traceability table is also placed at the end of the software requirement specification. So here we are coming to an end where we have concluded all these things that we are supposed to discuss in this lecture. First was inception, in which we identified the scope of the project and identify the key stakeholder along with the initial goals, and elicitation, in which we gather requirement and stakeholders using interview, surveys, and observation. Elaboration, refine and expand a vague requirement into a more clear and described structured specification. Negotiation, resolve conflicts, prioritize requirement and reach agreement with stakeholders. Specification, document the finalized requirements formally in this software requirements system. Validation, review and verify correctness for correctness and completeness of feasibility. Control requirement, changes the track version and maintain consistent throughout the project. Thank you for today's lecture. If you have any question, do let me know in the comment section. Do not forget to like, subscribe, and share with your friends. Take care. Allah Hafiz.